this is Britt Caswell with another video on examples from our textbook. This example is from section 1-5 in the SavvasRealize Algebra 1 textbook. It's example 1, solving inequalities. It's just a reminder, an inequality is a type of an equation that has multiple solutions. So usually when we talk about an inequality, we use four symbols. We use greater than or equal to, less than, and less than or equal to. So we're describing a range of values that satisfy that kind of situation. In this case, we're searching for the x values that cause the left-hand side of this equation to be greater than or equal to 16. Okay, and there's many different numbers I can choose that'll do that. So let's go ahead and start trying to solve it. Okay. When we say to solve it, we are usually talking about, let me zoom out a little bit, there we go. We're usually talking about solving just like you would with any other equation, okay? So I'm going to go ahead and draw my little river down at my inequality symbol. And then I'll approach this in the same way that I approach all my other equations. First, I deal with my grouping symbols. So I have a set of parentheses here that I'm going to distribute this -4 to. So I have 4 times -3 is -12x, because there's an x here. And -4 times -1 is a +4. And then all the rest of my equation stays the same. So I still have the plus 6x sneaking in there. Still have the greater than or equal to, and I still have the 16. One mistake that kids often make is they'll distribute and then forget that that 6x is there. So make sure, guys, that you guys are looking for what's left in the equation, because it doesn't just disappear when you distribute. So the next thing that I tend to do is I collect my like terms. So here I have a -12x. Here I have a plus 6x. That's a total of a -6x. Write in the rest of my equation. So now I'm at the point where I need to start moving things across the equal sign. So I'm trying to isolate my variable, which means to get this x by itself. So right now there's a -6 being multiplied to it, and there's a 4 being added to it. So I have to get rid of that addition and subtraction before I can get rid of any multiplication or division. So to get rid of an addition of 4, I'm going to subtract 4. So my equation turns into -6x is greater than or equal to 16 minus 4 is 12. And then to remove a multiplication of -6, I'm going to divide by -6. I have an x, 12 divided by -6 is -2. And this requires us to discuss what happens with the inequality symbol. So anytime you ever multiply or divide by negative value, this inequality flips around. He goes the other way. The way that I remember it is I learned inequality symbols as being alligators. And they're hungry alligators. They like to eat the biggest amount of food. And so when we multiply or divide by a negative number, it confuses the alligator because they don't know what negative numbers are. And they tend to go in the other direction. That's how I remember it. Ooh, zooming out real far now. Alright, so now let's talk about graphing it. So in order to graph it, because we only have one variable, we're going to do it on a number line. Alright, I'm going to put the numbers that go around -2, so I have a -3. Make sure that you have enough room to be able to show any shading to the side. Alright, so now we're going to put an anchor point at that -2. We know that right there is kind of where things start to cut off. Now in order to show which inequality symbol we're using, there's two things. One is the direction in which we shade. Okay, so all the values less than that -2 are to the left. But we need to have some kind of tool to help us to see how to show that it could be equal to. So remember, in order to show that equal to portion, we have to shade in the circle. So here at the top of the screen, the ones that are not equal to, we use the open circle. The ones that are equal to, we use the shaded circle like this. And there we have it. So here is the inequality solution, and then here is the graph solution. Let's try another one, just to make sure we really have it together. So I put my river down my inequality symbol. I have some grouping symbols, so we need to get rid of those by distribution. So negative 3 times 2x is negative 6x. Negative 3 times 2 is a negative 6. Still have my less than, and I still have my 10. So now we're trying to isolate x. We want x alone. So I have something being multiplied, pardon me, and I have something being subtracted. So I have to get rid of the subtraction first. So I'm going to go ahead and add 6 to each side of the equal sign. So this turns into negative 6x is less than 10 plus 6 is 16. And then, because I have something being multiplied to my x, I have to undo it by dividing. So I'm dividing both sides by negative 6. And that leaves me with x. My alligator's confused because we multiplied or divided by negative, so he changes directions. And then we have 16 over negative 6. It's a negative value. You can reduce this into 8/3, or you can plug it into your calculator. That's also okay. You get negative 2.666666 or 2.67. Alright, in a case like this, I usually prefer the fractional answer over the decimal, because the fraction is exact and the decimal, without that little line, is an approximation. So now let's graph it. Again, we have a single variable, so we're using a number line. We know we're going to need to go between negative 3 and negative 2. You don't have to go as crazy with the lines as I'm doing. I just was bad scaling. Okay, so negative 2.67 or negative 8/3. That's most of the way to negative 3, but not quite there. I'm going to use an open circle because it doesn't say that it's equal to. And then x is all the numbers greater than that, so I'm going to shade here where all the bigger numbers are. You see how when you go wild with your numbers on your number line, how you have to shade more? So it might be beneficial to really check your scaling on your number line. Another trick that algebra teachers tend to do to help you guys remember this is if you put the variable first, then the inequality symbol, then the number, this inequality symbol looks like it makes an arrow pointing in the direction you need to shade. But that only works if you have the variable first, then the inequality symbol, and then the number. Let's try just one last other one just to make sure we know. So I draw my little river at my inequality symbol. I have a set of parentheses, so I'm going to distribute to that set of parentheses. So 2 times 4 is 8, and 2 times negative 2 is negative 4x. Now we're trying to isolate x, we want to get it alone. And this is where kids tend to struggle a little bit because they see the multiplication and they see that they're subtracting the 4x, but they don't know how to get rid of the 8. So what I'm going to do, because 8 is positive, I'm just going to put a little plus right here to remind myself it's positive. And I think that makes it easier to see why we need to subtract it. Okay? It's a little odd, especially for kids just starting in Algebra 1. So here I have negative 4x is greater than 1 minus 8 is negative 7. And then this number squished against a letter, that's multiplication. So to undo it, I'm going to divide both sides by negative 4. So on this side, I'm left with x. On this side, A negative divided by a negative is a positive 7/4, or 1.75 if you guys are decimal people. And remember, when we multiply or divide by that negative, our inequality symbol, our alligator guy, gets confused and it faces the other way. So our answer, our solution, is that x is less than 7/4. So when I go to graph this, right, I have my numbers on my number line. 1.75 or 7/4 is almost all the way to 2. I don't have the line underneath my inequality symbol to show me that it's equal, so leave that point empty. And then I shade all the values less than that 7/4. So everything to the left. And that's it. That's our first example. Until next time.